Service Commission, Deputy Superintendent of Police, Police Telecommunication 2024, ECE question paper solutions part 5, that is question number from 122, question number 150. Question number 121. The Laplace transform of unit step function is. Correct option is A. For unit step function, Laplace transform is 1 by S. For a step function of magnitude A, Laplace transform is A by S. Similarly, for ramp function, Laplace transform is 1 by S square. For a parabolic function, Laplace transform is 1 by S cube. For a parabolic function of 1 by 2 t square into u of t, its Laplace transform is 1 by S cube. So the general formula is the Laplace transform of t power n is n factorial by s power n plus 1. S power n plus 1. So correct option here is A. Next question. Which of the following is not a condition for application of superposition theorem? So from the definition of superposition theorem, superposition theorem states that any linear bilateral network having multiple independent sources, the response across any element is equal to algebraic sum of responses of that particular element by considering each source at a time, provided that remaining sources are replaced by their internal resistances. This superposition theorem is not applicable for network containing nonlinear elements, for a circuit having initial conditions, and for power calculation since power is a nonlinear parameter. In the question it has been mentioned that which of the following is not a condition. The circuit must be linear. It is a condition. Circuit must only have independent sources. It is a condition. The circuit must have independent sources. So this option is not a condition. The circuit must be bilateral. It is also a condition. So correct option is C. The circuit must have independent sources. Next question. In a balanced three-phase star connected system, the line voltage is 400 volts. Then what is the phase voltage? For a balanced three-phase star connected system, line voltage is root 3 times of phase voltage. That is, line voltage is root 3 times of phase voltage, where phase voltage can be written as line voltage by root 3. So in the question it has been mentioned that line voltage is 400 volts. So that is VL is 400 volts divided by root 3. Its value is 230.94 volts. So that is approximately equal to 231 volts. So phase voltage is 231 volts. Correct option is B. Similarly, in a balanced three-phase delta connected system, line voltage is equal to phase voltage. So that is VL is equal to VP. Whereas in case of star connected system, line voltage is root 3 times of phase voltage. Next question. Two coils with self-inductance L1 is 1 Henry, L2 is 2 Henry, having the mutual inductance of 0.5 Henry. Find the coefficient of coupling between the coils. The coefficient of coupling K, it is defined as the fraction of magnetic flux produced by current in one coil that links with the other coil. This coefficient of coupling K is amount of coupling between two inductively coupled coils. And the formula for coefficient of coupling in terms of mutual inductance and self-inductance is mutual inductance M is equal to K root of L1 L2. So mutual inductance is 0.5 coefficient of coupling K square root of inductance 1 Henry, L2 is 2 Henry. So from this K is equal to 0.5 by root 2. The value of root 2 is 1.414. 0.5 can be written as 1 by 2 root 2. So it is 1 by 2.8284, that is 0.354. So coefficient of coupling K, its value is 0.354. Next question. A system has multiple poles at the same point on j omega axis. Then the system is. A system with multiple poles on j omega axis is unstable system. So let us see different cases here. The roots of characteristic equation, that is poles and nature of the system. All roots with negative real parts. All poles on on the left hand side of a S plane, then the system is absolutely stable system. If at least one root with positive real part, that is one pole on the right hand side of S plane, the system is absolutely unstable. Multiple poles at a same point on j omega axis, that is repeated roots on j omega axis, system is absolutely unstable. Roots on j omega axis, that is imaginary axis, system is marginally stable. Next question. When the tolerance is taken as 2%, the settling time of a system for damping ratio tau and frequency omega n is given as, for 2% tolerance, settling time Ts is 4 by settling time Ts is 4 by zeta omega n, where zeta is damping ratio, omega n is natural frequency. For 4% tolerance band, settling time Ts is equal to 3 by zeta omega n seconds, where zeta is damping ratio and omega n is natural frequency. So correct for in the question it has been mentioned 2% tolerance. So correct option is C, 4 by zeta omega n. So in the question it has been mentioned damping ratio tau instead of zeta. Next question. A type 1 system is subjected to a acceleration input signal, then the steady state error will be. So for a type 1 system, and the input given is acceleration input, that is parabolic input, then for this system steady state error is type 1 system with parabolic input, its steady state error is infinity. For type 1 system with step input, its steady state error is 0. So as per the question, for type 1 system with parabolic input, steady state error is infinity. Correct option is D. Next question. A system with characteristic equation s square plus 4s plus 10 is equal to 0 will be. What is the nature of the system? It has in the question it has asked. The standard time domain equation for second order system is, standard characteristic equation for second order system is s square plus 2 zeta omega ns plus omega n square is equal to 0. Compare this equation with given equation, that is s square plus 4s plus 10 is equal to 0. So here omega n square is 10, omega n is square root of 10 radian per second, 2 zeta omega n is 4. So from this zeta is 4 by omega n, 4 by 2 omega n, that is 2 root 10. 4 by 2 is 2 by root 10. So root 10 can be written as root 5 into, so its value is 2 by root 10, its value is obviously less than 1. So root 10 is more than 3, its value is less than 1. So if zeta is less than 1 and not equal to 0, the system is underdamped system. So correct option is A. For zeta is equal to 0, the system is undamped system. For zeta lies in between 0 to 1, the system is underdamped. If zeta is equal to 1, roots are real, equal and negative, system is critically damped. For zeta greater than 1, roots are real, unequal and negative, system is overdamped. Next question. The type and order of a system with transfer function 1 by s into s plus 1 are. So type of the system is number of open loop folds occurring at the origin. For the given transfer function, the number of open loop folds are only 1. So 1 by s is a open loop pole. So that is type of the system is 1 and the order of the system is number of closed loop poles in the transfer function. The total number of poles in closed loop transfer function are the highest power of s in the denominator. Given transfer function is 1 by s into s plus 1, that is 1 by s square plus s. So here the highest power in the denominator is 2. So number of poles are 2 and the type of the system is 1. Type of the system is 1 for a given transfer function, that is type 1 order 2. Correct option is C. Next question. A second order system exhibit 100% overshoots. Its damping coefficient is, the standard representation of second order system transfer function is T of s is equal to C of s by R of s omega n square by s square plus 2 zeta omega ns plus omega n square. Here the characteristic equation is s square plus 2 zeta omega ns plus omega n square is equal to 0, where zeta is damping ratio, omega n is undamped natural frequency. So we know that maximum peak overshoot mp is equal to e power minus pi zeta by square root of 1 minus zeta square. In the question it has been given 100% overshoot, so it is 1. So it is 100% is its value is unity, so maximum peak overshoot is 1 e power minus pi zeta by square root of 1 minus zeta square. So taking e to this side, so it will become log 1. Log 1 is 0, therefore minus pi zeta by square root of 1 minus zeta square is 0. So from this numerator term is 0, pi zeta is equal to 0. So pi is a constant, therefore zeta is 0. Damping ratio is 0. Damping ratio is 0. A second order system exhibit 100% overshoot, then its damping coefficient is 0. Correct option is A. Next question. A lag network for compensation generally consists of, this is a circuit diagram for lag network. So it consists of RC elements in series at the output side. RC elements in series at the output side. Also given the pole 0 representation of lag network. So here pole is dominant over 0. For lag network, pole is dominant over 0. Correct option is B. RC in series with the output side. So let us see lead compensator. In lead compensator, only resistor at the output side. At the input side, capacitor and resistor are in parallel to each other for lead compensator. In lead compensator, 0 is added, whereas in lag compensator, pole is added. In a lead compensator, 0 is more dominant, so this 0 is more dominant over the pole. So let us see differences between lead compensator and lag compensator. In lead compensator, 0 is added, lag compensator, pole is added. So lead compensator is differential term, high pass filter, integral term, band pass, low pass filter. In lead compensator increases the bandwidth of the system, lag compensator decreases the bandwidth. So with lead compensator, marginal stability increases, system becomes more stable. In with lag compensator, marginal stability decreases, system stability gets decreased. System becomes less stable. Next question. If a PID controller is applied for a controlling system, then it decreases the steady state error. PID controller decreases the steady state error and improves the transient response. Correct option is C. PID controller is similar to lead lag compensator. It improves both steady state response as well as transient response, reduces the rise time. If rise time is reduced, obviously bandwidth gets increased, steady state error decreases, stability gets improved. It decreases the steady state error and improves the transient response. With this lead lag compensator, increases the type and order of system by 1. Type is increased by 1 and order of the system is also increased by 1. So correct option is C. Next question. A substance can be piezoelectric only if the unit cell lacks a center of inversion. So correct option is A. So the substance or a crystal can exhibit piezoelectric effect or the crystal have piezoelectric nature only if its unit cell lacks a center of inversion. Correct option is A. Next question. For an extrinsic semiconductor at constant room temperature, the product of number of electrons and holes is as below. So the product of, according to the law of mass action for an extrinsic semiconductor at a constant temperature, the product of electron concentration and hole concentration is equal to square of intrinsic concentration, that is remains constant. Electron concentration and hole concentration, electron concentration is N, hole concentration is P, it remains constant, that is square of intrinsic concentration. Correct option is A. Next question. Physical origin of superconductivity lies in the interaction between the following: conduction electrons and the ions of lattice. The physical origin of superconductivity lies in the interaction between the conduction electrons and ions in the lattice. The physical origin of superconductivity is due to the interaction between conduction electrons and the ions of the lattice. This interaction causes electrons to pair up, forming Cooper pairs that move through the lattice without any friction. So correct option is B. Next question. The electrical resistivity rho in a conductor is given by, we know that conduction current density J is equal to NQ Vd, where N is electron concentration, Q is charge of electron 1.6 into 10 power minus 19 coulombs, Vd is drift velocity. This conduction current density J can be written as sigma E is equal to NQ Vd. So from this 1 by sigma it can be written as rho, where sigma is conductivity, rho is the resistivity, rho is equal to 1 by sigma. So from this resistivity rho is equal to E by NQ Vd. So E by NQ Vd, replace this drift velocity with Q E by M into tau. So electric field get cancelled in numerator and denominator, and it will become resistivity rho is equal to N Q square tau, where tau is the lifetime of a charge carrier, N is electron concentration, Q is charge 1.6 into 10 power minus 19, M is the mass of charge. So from this electrical resistivity rho in a conductor is given by M NQ square into tau ohm meter inverse. So correct option is A. So here Q is 1.6 into 10 power minus 19 coulombs, M is a electron mass of electron, N is electron concentration, number of electrons per cubic meter or cubic centimeters. The one more formula for resistivity, R is equal to rho L by A. From this, R is a resistance in ohms, resistivity is ohm meter. The correct is ohm meter, resistivity is ohm meter. Conductivity, units of conductivity is ohm meter inverse. Here electrical conductivity rho in conductors is M NQ square tau. Correct option is A. Next question. A high Q quartz crystal exhibits series resonance at frequency omega s and parallel resonance at frequency omega p. Then the relation between series resonance and parallel resonance is: omega s is very close but lesser than omega p. So here Fp is series resonant frequency, Fp is series resonant frequency, Fp is parallel resonant frequency, Fs is series resonant frequency, x-axis that is frequency and y-axis crystal reactance. So from this graph, if frequency greater than Fs, when frequency is greater than Fs, the crystal reactance is inductive. If frequency less than Fs, crystal reactance is capacitive. In between Fs and Fp, the crystal reactance is inductance. If the frequency is greater than Fp, the nature of crystal reactance is capacitive in nature. So as per the question, this series resonant frequency omega s and parallel resonant frequency omega p are close to each other. These are close to each other, and series resonant frequency is less than parallel resonant frequency. Correct option is D. So this is a circuit symbol and equivalent circuit of crystal oscillator. Next question. Optical material having isotropic crystal structure is gallium arsenide. So this LiNbO3, lithium niobate, and KDP, potassium dihydrogen phosphate. This doesn't exhibit isotropic. This doesn't have isotropic crystal structure, and the optical material having isotropic crystal structure is gallium arsenide. Next question. The Boolean expression A plus A bar B is equivalent to. So from distribution theorem of x plus pq is equal to x plus p into x plus q. So given Boolean expression is A plus A bar B. Here p is A bar, q is B. So according to distribution theorem, A plus A bar into A plus B. So we know that x plus x bar, the variable plus the complement of variable is 1. 1 into A plus B. So that is A plus B. So correct option is B. Next question. Flip flop is also known as. So flip flop or binary or Eccles Jordan circuit or scale of 2 toggle circuit. It is nothing but a bistable multimeter. So different names of bistable multimeter are flip flop or binary, Eccles Jordan circuit, scale of 2 toggle circuit. Next, similarly for a stable multivibrator, it is also known as free running oscillator or a square wave generator. So this bistable multimeter has two stable states. Number of stable states are 2 and 0 unstable states are astable states. So for a stable multivibrator, number of stable states are 0, but number of unstable or astable states is 2. Next question. Which of the following is known as non-saturated logic? This emitter coupled logic ECL is non-saturated logic. It is also called current mode logic or current steering logic, and it is the fastest of all logic families because the transistors are not allowed to enter into saturation. Transistors are prevented from entering into saturation. Here in ECL, transistors are allowed to operate only in cutoff region and active region. Therefore, ECL is non-saturated logic. Here RTL, resistor transistor logic, DTL, diode transistor logic, TTL, transistor logic. These are the other options. These are saturated logic families. Next question. PLA is similar to ROM in the concept except that PLA, programmable logic array, is similar to read-only memory in the concept except that it doesn't provide PLA doesn't provide full decoding of variables and does not generate all the minterms as in ROM. Correct option is C. It does not provide full decoding to the variables. Next question. Question number 143. If the input of a T flip-flop is 100 Hz signal, so 100 Hz signal is given as input to a T flip-flop. What is the final output? What is the frequency output when 3 T flip-flops are connected in cascade? So we know the formula. So output frequency is input frequency by total number of states. So here number of flip-flops are connected in cascade is 3. So from this total number of states is 2 cube, that is 8. Now The output frequency FO is input frequency 100 by total number of states 2 cube, that is 8. 100 by 8, it is 12.5 hertz. Output frequency is 12.5 hertz. Correct option is B. Next question. In a JK flip flop, toggle means. So this is a JK flip flop. In JK flip flop, if 0 0, truth table of JK flip flop, for input 0, J input 0 and K input 0. So next state Qn plus 1 is same as previous state Qn. There is no change of state. If J0, K1, so that is next state Qn plus 1 is reset. If J is 1, K is equal to 0, next state Qn plus 1 is set. Similarly, if both inputs are 1, so the next state is complement of present state, that is Qn plus 1 is equal to Qn bar. So the flip flop gets toggle. Correct option is D. Change the output to a opposite state. Flip flop gets toggles. Next question. The Boolean expression for the output F of a multiplexer shown below is. So this is a given multiplexer. A, B are the selection lines and C is the input lines. So here it is I naught. For input I1 it is C bar. Input I2 it is C bar. For input I3 it is C. So it can be written as A bar B bar into I naught, AB bar into I1, it is A bar B into I1, AB bar into I2 plus AB into I3. So that is A bar B bar, I naught is C, A bar B, I1 is C bar, AB bar, I2 is C bar plus AB, I3 is C. So here A bar B bar plus AB of C, A bar B, AB bar, C bar. Take it as X. So it is X bar. So it can be written as XC plus X bar, other variable C bar. So this is A XOR B XOR C. Correct option is A XOR B XOR C. Correct option is C. So we know that A bar B plus AB bar is equal to A XOR B. So it can be written as A XOR B into C bar. This A bar B bar plus AB, that is complement of A XOR B, A XOR B. So here it is A XOR B. So final output F is equal to A XOR B XOR C. Next question. The number of control lines in 8:1 multiplexer. So these decoders, encoder, multiplexer, demultiplexer, these are combination logic circuits. For decoder, it is a combination logic circuit with n input lines, 2 power n output lines and 1 selection lines. For encoder, 2 power n input lines, n output lines and 1 selection lines. In the question it has given multiplexer. A multiplexer is a combination logic circuit with 2 power n input lines, 1 output line and n selection lines, and the opposite to multiplexer is demultiplexer. So multiplexer is a combination logic circuit with 2 power n input lines and 1 output lines, where n is the number of selection lines. It has mentioned 8 is to 1 multiplexer. So 8 is to 1 is 2 cube by 1 multiplexer. So this 2 cube by 1 multiplexer, n is 3. The number of selection lines are 3. Correct option is B. Next question. EPROM contents can be erased by exposing it to. This EPROM stands for Erasable Programmable Read-Only Memory, EEPROM, Electrically Erasable Programmable Read-Only Memory. So once EPROM is programmed, this EPROM contents can be erased by exposing it to strong ultraviolet ray, strong UV light source. Similarly, the contents of EEPROM are erased by using electrical signals. EPROM is a older technology compared to EEPROM. In this EPROM, chips must be removed from the circuit to be programmed or erased, whereas in case of EEPROM, it is a modern technology. Chip can be programmed or erased while it is in the circuit. Correct option here is by exposing this EPROM to ultraviolet rays, the data can be erased, contents can be erased. Next question. The digital logic family which is having minimum power dissipation. So the power dissipation is minimum for CMOS and the highest power dissipation is for ECL. So emitter coupled logic, complementary metal oxide, semiconductor logic. Complementary metal oxide, semiconductor logic. Power dissipation is least for CMOS. Correct option is D. Next question. For a series RLC circuit, making resistance R0, setting resistance will produce, setting R is equal to 0 in series RLC circuit produces undamped response because there is a mechanism to dissipate energy. This leads to infinite oscillations without decay. Undamped response. Series RLC circuit with non-zero capacitance might exhibit overdamped, critically damped, or underdamped behavior depending upon the values of RLC. For underdamped, R less than 2 by square root of LC or R square by 4L square less than 1 by LC, then the nature of series RLC circuit is underdamped. If resistance R is equal to 2 times of square root of L by SC, then series RLC circuit is critically damped. For overdamped resistance R, the value of resistance R should be greater than 2 square root of L by C. In the question it has been mentioned R is equal to 0, then the nature of response is undamped. So option A is overdamped, option B critically damped, option C underdamped. So none of the above. Correct option D. Next question. The time constant of a circuit is, so generally the time constant of RC circuit is tau is equal to R equivalent into C equivalent. Here two resistors are connected in parallel, therefore R equivalent is R1 R2 by R1 plus R2. The two resistors are of same value. Equivalent resistance is R by 2. If two capacitors are connected in parallel, then equivalent capacitance is C1 plus C2. Here two resistors are same, that is 2C. R equivalent is R by 2. C equivalent is 2C. The time constant of the circuit is R into C. Correct option B.